There is a fantasy that sits at the very heart of our modern mythology, a vision that has captured the human imagination ever since we first realized that the stars were other suns and that the darkness between them was deep enough to hold secrets. It is the fantasy of the advanced extraterrestrial civilization. We have all seen them in our cinema, read about them in our literature, and perhaps, in the quiet moments of the night, hoped for their arrival. We imagine beings who have transcended the petty squabbles of their home worlds, who have shed the biological frailties that plague us, and most importantly, who have solved the riddle of the cosmos. We imagine that for a civilization 1,000,000 years older than our own, a blink of an eye in the 14 billion year history of the universe, the laws of physics that bind us to this rock would be nothing more than suggestions, archaic rules to be bent or broken at will. We assume that with enough time and enough intelligence, the barriers of space and time dissolve. We picture their ships gliding effortlessly between the stars, crossing the vast, freezing voids of the galaxy as easily as we might cross an ocean, defying gravity, defying inertia, defying the very structure of reality itself. It is a beautiful, romantic, and profoundly humbling thought. It suggests that we are merely children in a nursery, waiting for the adults to arrive and show us how the universe really works. But there is a different perspective, one that is perhaps less romantic in the traditional sense, but far more profound in its implications. It is a perspective grounded not in wishful thinking, but in the hard, cold, and beautiful truths that we have discovered about the nature of existence. And that truth is that the universe is not a puzzle box with a hidden solution that unlocks unlimited power. The universe is a structure, a rigid, unyielding framework built upon fundamental constants and immutable laws. And the most uncomfortable, yet most magnificent realization we must face is that these laws are not local ordinances. They are not rules that apply only to us because we are primitive or because we inhabit a quiet backwater of the Milky Way. They are the bedrock of reality. And this means that the same physical limits that keep us trapped on Earth, the same barriers that make space travel so agonizingly difficult and energy intensive for human beings, apply with equal and devastating force to anyone else, anywhere else, no matter how intelligent, no matter how advanced, no matter how old their civilization might be. The aliens are trapped, just as we are. And to understand why, to truly grasp the magnitude of this cosmic imprisonment, we have to look at the first and most formidable wall of our prison cell, the speed of light. When we talk about the speed of light, we often make the mistake of thinking of it as a speed limit in the conventional sense, like a sign on a motorway telling us not to exceed 70 miles per hour. We think of it as a technical challenge, an engineering hurdle. We tell ourselves, well, we broke the sound barrier, didn't we? Surely, with enough cleverness, we will break the light barrier too. But this analogy is deeply flawed. The speed of light, denoted by the letter c in the equations of relativity, is not really about light at all. It is about causality. It is about the speed at which one event in the universe can influence another. It is the speed of gravity, the speed of information, the speed of reality unfolding. It is the maximum frame rate of the cosmos. To go faster than light is not just to move quickly. It is to arrive before you have left. It is to rearrange the sequence of cause and effect upon which the logic of the universe is built. For any species, anywhere in the universe, to accelerate a massive object, be it a spacecraft, a probe, or a living being, to this speed, requires an amount of energy that is not just large, but infinite. This is the diktat of special relativity, a theory that has withstood a century of the most rigorous testing human beings can devise. As an object approaches the speed of light, its mass in effect, its resistance to further acceleration increases. As you push harder, the universe pushes back harder, you pour more and more energy into the engines, but you get less and less speed in return. By the time you are skimming the edge of that ultimate limit, you are feeding the kinetic energy of entire stars into your motion, and still that final barrier recedes before you. To reach the speed of light, you would need infinite energy, and you would become infinitely heavy. There is not enough energy in the entire observable universe to accelerate a single grain of sand to the speed of light. Now, proponents of the advanced alien theory will argue that there must be loopholes. They will speak of warp drives, of folding space-time, of wormholes, of Alcubierre metrics, concepts that exist in the towering mathematics of general relativity. And indeed, on paper, the equations allow for such geometries, but the universe is not just mathematics, it is physical stuff. To build a warp drive, to bend space-time in a way that allows you to cheat the distance, requires a form of energy density that is negative. It requires exotic matter, a substance that has never been observed, that may not exist, and that, if it did exist, would violate other fundamental energy conditions that hold the universe together. It implies a mastery over the fabric of space that requires the energy output of the entire galaxy focused into a space smaller than an atom. Even for a civilization that can harness the power of 1 billion suns, the engineering reality of manipulating space-time on that scale runs headlong into the chaotic, destructive nature of quantum mechanics. The moment you try to build that bridge, the vacuum itself fights back with radiation intense enough to sterilize a solar system. So let us assume, reasonably and conservatively, that the speed of light is indeed the absolute speed limit for everyone. What does that mean for our hypothetical aliens? It means that the galaxy is not a connected village. It is an archipelago of isolated islands separated by oceans so vast that they defy the biological intuition of any creature that evolved on a planet. Consider the distances. Our own galaxy, the Milky Way, is a disk of stars 100,000 light years across. Light, travelling at 186,000 miles per second, fast enough to circle the Earth 7 times in a single heartbeat, takes 100,000 years to cross it. Even if an advanced civilization could build ships that travel at 10% of the speed of light, a feat that is monumental, requiring engines and fuel reserves that border on the impossible, it would take them 1 million years to cross the galaxy. 1 million years. That is not a journey, that is an epoch. In 1 million years, species evolve and go extinct. Stars are born and die. Continents drift and reshape the surface of planets. The civilization that launched the ship would likely be dust and memory by the time the vessel reached its destination. This tyranny of distance imposes a profound limit on the structure of any potential galactic society. We often imagine galactic empires, vast federations, where a central government on a capital world administers colonies thousands of light years away. We imagine trade routes, diplomatic envoys, interstellar wars. But think about the communication lag. If you are a colony only, and I say only with a heavy dose of irony, 100 light years away from your homeworld, a message sent to the capital takes a century to arrive. The reply takes another century to return. A simple exchange of hello, how are you, takes 200 years. You cannot have a conversation. You cannot have trade. You cannot have governance. If a crisis emerges on the colony, the home world will not know about it until everyone involved has been dead for decades. Therefore, any alien civilization is, by the physical necessity of the speed of light, localized. They might spread to a few nearby stars. Perhaps if they are incredibly patient and willing to hurl themselves into the void for generations. But they will not be a unified entity. As soon as a colony is established light years away, it is severed from its parent. It becomes a new world, independent, evolving on its own trajectory, culturally and biologically drifting apart. The empire is impossible not because of politics, but because of physics. The universe enforces a kind of cosmic quarantine, ensuring that civilizations remain pockets of complexity, separated by insurmountable silence. But the speed of light is only the first wall. There is another constraint, one that is perhaps even more vicious, because it deals not with the cannot of motion, but with the cost of existence. This brings us to the currency of the universe, energy. We often assume that advanced aliens will have solved the energy crisis. We speak of the Kardashev scale, type I, civilizations that harness a planet, type I that harness a star, type I that harness a galaxy. We assume that with fusion power or antimatter or zero-point energy, they will have limitless resources to power their grand ambitions. But here we collide with the most depressing yet most robust law in all of physics, the second law of thermodynamics. Thermodynamics is the study of heat and energy, but in a deeper sense, it is the study of inevitability. The second law states, quite simply, that entropy always increases, disorder always grows. But the crucial corollary for our alien friends is that no process is 100% efficient. Whenever you do work, whether it is thinking a thought, moving a muscle, or accelerating a starship, you must pay a tax to the universe in the form of waste heat. This is not an engineering flaw. It is not something that you can invent your way out of with better technology. It is a fundamental property of how energy interacts with matter. Imagine an alien civilization that builds a computer the size of a planet to simulate their reality or to calculate the path to the stars. That computer requires energy to run. As it processes information, it generates heat. This heat must be radiated away, or the computer will melt. The more powerful the civilization, the more energy they use. The more energy they use, the more heat they generate. If they build a Dyson sphere, a shell, around their star to capture all its solar output, they are essentially trapping themselves inside an oven. The laws of radiation dictate that the sphere must radiate that heat outwards, or the star inside will boil the civilization alive. To an outside observer, a Type 2 civilization wouldn't look like a glorious city of light. It would look like a massive source of infrared waste heat, a glowing ember of entropy. This applies even more brutally to space travel. We have established that they cannot go faster than light. But even to go near the speed of light requires energy expenditures that are truly frightening. To accelerate a ship the size of a typical ocean liner to just half the speed of light requires more energy than the entire human race consumes in centuries. And that is just to get up to speed. You also have to stop. That means you need to carry enough fuel to decelerate, which adds mass, which means you need more fuel to accelerate, the fuel you need to decelerate. This is the tyranny of the rocket equation, and it holds true whether you are burning kerosene, fusing hydrogen, or annihilating antimatter. The universe does not give refunds on momentum. Every ounce of speed must be bought with a colossal expenditure of energy, and every joule of energy generates waste. For a biological creature, or even a silicon-based machine intelligence, traveling between the stars is not just a matter of time, it is a matter of resource management on a planetary scale. Is it worth bankrupting your home world's energy reserves to send a probe to a star system that might have life, knowing that the data won't return for 1,000 years? Even for a hyper-intelligent species, the answer is likely to be a pragmatic no. The economics of interstellar travel are appalling. The return on investment is effectively zero. We project our own expansionist desires onto these aliens. We are explorers, we say. We climbed Everest, we crossed the Atlantic, we went to the moon. Surely any intelligence would possess this same drive to conquer the frontier. But the frontier of space is not like the Atlantic Ocean. It is not a challenge of courage. It is a challenge of basic physics. The Atlantic Ocean did not require Columbus to convert the mass of a mountain into pure energy just to leave the port. The scaling laws of the universe are not linear. They are exponential. What is possible on a planetary surface becomes difficult in orbit, improbable in the solar system, and effectively impossible across the interstellar void. And this leads us to a realization about the materials themselves. We often think of aliens as having super materials, unbreakable hulls, perfect shields, engines that never fail. But the periodic table of elements is universal. Carbon is carbon in the Andromeda galaxy, just as it is in Leeds. Iron is iron. The bonds that hold atoms together are governed by the same quantum electrodynamics everywhere. There is no unobtainium. There is no magic metal that is light as a feather and harder than diamond, and can withstand the impact of a dust grain hitting it at half the speed of light. When you travel at relativistic speeds, the interstellar medium, the tenuous gas and dust that floats between the stars, is no longer a vacuum. It becomes a stream of high-energy radiation. A single proton, stationary relative to the galaxy, becomes a cosmic ray bullet when you slam into it at nearly the speed of light. To a ship moving that fast, the gentle drift of hydrogen atoms becomes a relentless bombardment of ionizing radiation that would strip away electrons, degrade materials, and destroy DNA or complex circuitry. To shield against this, you need thick, heavy armor. But armor adds mass. Mass requires more energy to accelerate. We are back in the loop. The prison of light is not just a speed limit. It is a physical barrier of radiation and impact forces that makes high-speed travel a suicide mission for any complex structure. So we have a picture emerging, not of gods who can snap their fingers and appear in our skies, but of civilizations that are bound tightly and irrevocably to the stars that gave them birth. They are subject to the same equations of motion, the same conservation of energy, the same structural limits of matter. They look up at the night sky and see the same taunting beauty that we do, a universe that is tantalizingly visible but physically out of reach. But let us go deeper. Let us assume that they are stubborn. Let us assume that they are willing to pay the energy cost, willing to wait the millennia, willing to brave the radiation. There is still a factor we have not considered, a factor that is perhaps the most fragile and limiting of all. It is not the ship or the engine or the fuel. It is the passenger. We must consider the biology of the alien. We tend to treat biology as a secondary concern in space travel, something that can be fixed with cryosleep or genetic engineering. But biology is not a software patch. It is the result of billions of years of adaptation to a specific environment. And the environment of space is the antithesis of life. Life, by its very definition, is a localized system that maintains low entropy by consuming energy from its surroundings. It is a delicate balance of chemistry, temperature, and pressure on Earth. We are shielded by a magnetic field and a thick atmosphere. We are held by gravity that is just right, not too crushing, not too weak. We are bathed in radiation from the sun that is filtered to a manageable level. Take a living thing, any living thing, and place it in the void. It is not just the lack of air. It is the cosmic rays that shatter chromosomes. It is the microgravity that causes bones to dissolve and fluids to shift, confusing the organs that evolved to work against a constant downward pull. It is the isolation, the sensory deprivation, the psychological horror of being a speck in an infinite dark room. If aliens exist, they evolved. They did not appear fully formed as cyborgs. They grew out of the muck of their homeworld, shaped by the specific gravity, the specific atmospheric mix, the specific light of their star. They are tuned to their home frequency. To take them out of that environment is to subject them to stress that their biology was never designed to handle, even if they are machines. Let us say they have uploaded their minds into silicon, they are still physical objects. Silicon degrades, transistors fail, data corrupts in the harsh radiation environment of interstellar space over the course of thousands of years. The very integrity of the mind would be under siege. Error correction codes can only do so much before the accumulated noise of the universe washes away the signal. A machine intelligence travelling for 10,000 years might arrive at its destination as nothing more than a glitching, senile ghost, its memory banks riddled with the cosmic equivalent of dementia. Thus, the prison is not just made of light and energy, it is made of complexity. The universe permits simple things, protons, photons, rocks, to travel vast distances, but complex things, things with minds, with structures, with intent, the universe seems to conspire against their movement. It degrades them, it bombards them, it isolates them, and this brings us to a somewhat melancholy, yet clarifying interim conclusion. The reason we have not met aliens is not because they are hiding. It is not because they are avoiding us. It is because the journey is too hard. It is because the laws of physics are not just equations to be solved. They are the walls of a very large, very quiet house. We are all in our separate rooms, and the walls are too thick to shout through, and the corridors are too long to walk down. However, simply saying it is impossible physically is only half the story. There is a deeper layer to this limitation, one that arises from the very nature of evolution and time itself. If the laws of physics set the stage, then the laws of biology and evolution write the script. And as we shall see, the script does not favour the wanderer. It favours the one who stays. The limits that apply to their bodies and their societies are just as rigorous as the limits that apply to their starships. And understanding this biological inevitability will show us that even if they could build the ships, they almost certainly wouldn't want to leave. So we find ourselves facing a universe that is not a playground, but a cage, a beautiful, shimmering cage made of light and distance, where the bars are defined by the speed limit of causality itself. But let us suppose, for a moment, that our hypothetical extraterrestrial friends are not discouraged by the sheer vastness of the void. Let us imagine that they have accepted the long silence, that they are willing to spend millennia drifting between the stars in their arcs, asleep or suspended in some technological stasis. We might think that once they arrive, once they bridge that terrible gap, they can begin to build the empires of our science fiction dreams. We imagine them dismantling planets to build Dyson spheres, harvesting the entire output of their stars, turning galaxies into vast, ticking machines of computation and industry. But here, they run headlong into a second wall, one that is perhaps even more unforgiving than the speed of light. It is a wall made not of distance, but of disorder. It is the tyranny of the second law of thermodynamics. You see, there is a fundamental rule in physics that is often quoted but rarely felt in its full, crushing weight. Entropy always increases. In any closed system, disorder grows, energy spreads out, structures degrade. This is not just a tendency, it is the arrow of time itself. And it carries a price tag that applies to every single action taken by every single entity in the cosmos, from the smallest bacterium to the largest galactic civilization. That price tag is heat. We have this notion, born of our current technological infancy, that efficiency is a curve that goes up forever. We think that if we just get smart enough, we can build machines that run on nothing, engines that produce no waste, civilizations that leave no footprint. But the laws of thermodynamics are not subject to innovation. They are the conditions under which innovation happens. Every time you process a bit of information, every time a neuron fires in an alien brain or a transistor switches in an alien supercomputer, you are converting useful energy into useless heat. This is known as Landauer's principle. Information is physical. Thinking costs energy. Computing costs energy. And that energy does not disappear. It degrades. It turns into vibration, into infrared radiation, into heat. Now, consider the type II civilization on the Kardashev scale, the one that has encased its star in a shell to capture all its energy. This is a staple of our futuristic fantasies. We imagine these beings living on the inner surface of a sphere the size of Earth's orbit, with the surface area of 1 billion worlds, bathed in eternal sunlight, with unlimited power at their fingertips. It sounds like paradise. But in physical reality, it is a furnace. If you capture the energy of a star, you must use it. And when you use it, it becomes waste heat. That heat has to go somewhere. If you have built a shell around your star, the heat has nowhere to go but into the shell itself. The structure begins to warm up. If you do not find a way to radiate that heat out into the cold dark of space, your civilization cooks itself. The laws of blackbody radiation dictate that to get rid of the heat generated by a star, your Dyson sphere must glow. It must shine brightly in the infrared part of the spectrum. This leads to a profound observation about our galaxy. If these civilizations existed, if they were out there building these megastructures, they would be blindingly obvious to our telescopes. They wouldn't look like stars. They would look like giant glowing embers. We have surveyed the sky with infrared telescopes like IRAS, Spitzer, and now the James Webb Space Telescope. We have looked at millions of galaxies, billions of stars, and what have we found? We have found dust. We have found forming stars. We have found the cold, quiet background of the universe. But we have not found the characteristic heat signature of a galaxy-spanning civilization. We see no Dyson spheres. We see no Fermi bubbles of waste heat. The silence is not just in radio waves. The silence is thermodynamic. The universe is not hiding them. The universe is telling us that they are not there, or at least they are not breaking the laws of thermodynamics on a grand scale. They are not reshaping galaxies because, quite simply, the energy cost of doing so creates a waste management problem that is unsolvable. You cannot cheat the heat. You can move it, you can spread it, but you cannot destroy it. An empire that tries to grow infinitely eventually drowns in its own entropy. This thermodynamic constraint leads to a different kind of limit, a limit on complexity and maintenance. We tend to think of advanced civilizations as static, perfect things. Once you build the Starship Enterprise, it just exists. But in the real universe, things break. The more complex a system is, the more energy is required simply to keep it from falling apart. Imagine a civilization that spans 10 stars. They have built colonies, mining outposts, relay stations. All of these are subject to the bombardment of cosmic rays, the impacts of micrometeoroids, the fatigue of metal, the corruption of software. The maintenance budget of a galactic empire scales exponentially. You need robots to fix the ships, but then you need robots to fix the robots, and factories to build the spare parts, and transport ships to move the parts between stars, transport ships that, as we established, take decades or centuries to arrive. The sheer logistical nightmare of fighting entropy over light years is the reason why empires on Earth crumble, and it is the reason why galactic empires are physically implausible on Earth. The Roman Empire collapsed because it took too long to send a legion from Rome to the borders of Britannia. Messages took weeks. Corruption and rot set in faster than the central authority could act. Now, scale that up to the galaxy. If a rebellion, or a plague, or a system failure occurs on a colony world, and the Emperor is 500 light years away, the colony is dust before the request for help even reaches the halfway point. Gravity, too, plays its part in this comedy of limits. We dream of terraforming, turning Mars blue or Venus green. We imagine aliens who can reshape planets at will. But think about what a planet is. It is a ball of rock, bound by its own gravity, with a specific chemical composition. To change the atmosphere of a planet like Mars, you need to import quintillions of tons of gas. You need to shield it from the solar wind. You need to heat the core. The energy required to do this is not just a lot, it is a significant fraction of the binding energy of the planet itself. And where do you get the materials? This is the problem of resource scarcity, which is just as real for aliens as it is for us. The universe, for all its vastness, is remarkably stingy with the good stuff. Hydrogen and helium are everywhere. That's the fuel of stars. But the elements of life and technology, carbon, nitrogen, oxygen, silicon, iron, gold, rare earth metals, these are trace contaminants in a universe of gas. If an alien civilization wants to build a fleet of 1 million starships, they cannot just replicate them out of thin air. They need iron. They need titanium. They need conducting polymers. To get these, they have to mine rocky planets or asteroids. They have to dig. They have to refine. This is dirty, energy intensive, difficult work. There is no magic wand in physics that allows you to transmute lead into gold without paying a nuclear energy cost that makes the process pointless. So the alien economy is bound by the same laws of supply and demand, the same scarcity of raw materials, and the same difficulty of extraction that we face. They do not have infinite resources. A planet only has so much crust. An asteroid belt only has so much metal. When they use it up, they have to move on. And moving on, as we know, involves crossing the impossible voids. This creates a trap. To get more resources, you need to travel. To travel, you need massive amounts of resources. There comes a tipping point where the energy cost of going to the next star system to mine its asteroids is greater than the energy you would get back from those asteroids. It becomes a net loss. The civilization stops expanding, not because it wants to, but because it goes bankrupt in terms of energy return on investment. This realization strips away the magical aura we have placed around extraterrestrial intelligence. We treat them as wizards, but they are actually engineers and economists, struggling against the same cosmic ledger that we are. They are counting joules. They are measuring grams of mass. They are worrying about heat dissipation. They are looking at their limited supply of heavy metals and wondering if it is really worth building that next habitat, or if they should just make do with what they have. And this leads us to the most subtle yet most powerful realization of all. If the laws of physics make expansion difficult, and the laws of thermodynamics make it inefficient, and the distribution of resources makes it expensive, then the trajectory of an advanced civilization is not outward, but inward. Why would you spend 10,000 years and the energy output of a sun to fly to a distant rock that is effectively identical to the rock you are already standing on? If you have mastered technology, if you have understood the laws of nature, the logical path is not to conquer the galaxy. It is to optimize your home. It is to miniaturize. It is to create a civilization that is in perfect equilibrium with its biosphere and its star. The advanced alien is not the one in the giant dreadnought spaceship looming over our cities. That is a primitive projection of our own colonial history. The truly advanced alien is the one that has learned to live on its home world for 1 billion years without destroying it. They are the ones who have realized that more is not better. They have realized that the infinite is not found in the span of light years, but in the depth of complexity, in the richness of information, in the stability of existence. We look for them in the wrong way. We look for their exhaust plumes, their Dyson spheres, their noisy conquests. But if they are wise, and they must be wise to survive the filter of their own technology, they will be quiet, they will be efficient. They will be gardeners of their own world, not strip miners of the galaxy. They will have learned the lesson that we are just beginning to grapple with, that there is no planet B, even for them. The grass is not greener on the other side of the nebula. It is just as hard, just as cold, and just as empty. But there is one final component to this machine of civilization. We have spoken of the ship, the fuel, the heat, and the metal. But we have not yet spoken fully of the mind that commands it. We touched upon biology earlier, but we must understand that biology is not just a fragile sack of water. It is a process. It is an evolutionary algorithm that has run for billions of years to produce a creature that is specifically designed not to leave. The aliens are not just trapped by gravity and entropy. They are trapped by their own nature. They are trapped by the very evolutionary success that allowed them to build the rockets in the first place. Because to build a rocket, you need intelligence. To have intelligence, you need a brain. To have a brain, you need a body. And to have a body, you need a history, a long, bloody, competitive history on the surface of a planet that taught you to fight, to consume, to reproduce, and to fear. We often imagine that aliens will be pure energy or beings of light, devoid of the primal instincts that drive us. But this is biologically incoherent. Evolution does not select for being profound. It selects for survival. It selects for the creature that wants to eat, that wants to claim territory, that wants to protect its kin. Any intelligence that arises in the cosmos must, by necessity, have these drives. If they didn't, they would have been eaten by the thing that did have them back in their primordial soup. So, when we imagine them in their starships, we must imagine them with all the baggage of a biological species. They will have politics. They will have factions. They will have disagreements. They will have fear. And this brings us to the sociology of the interstellar void. Can a society hold together when communication takes centuries? Imagine a ship sent to colonize a planet 20 light years away. The journey takes, let's say, 500 years. The people who arrive are not the people who left. They are the great-great-grandchildren. They have never seen the homeworld. They have no memory of the government that sent them. They have evolved their own culture, their own dialect, their own values in the dark confinement of the ship. When they finally land, do they feel loyalty to the homeworld? Of course not. They are a new species, effectively. The connectivity that defines a civilization, the shared culture, the shared laws, the shared identity, is severed by the delay of light. A galactic empire is impossible not just because of energy, but because it cannot remain culturally coherent. It shatters into thousands of isolated fragments the moment it tries to expand. The alien civilization is not a monolith. It is a scatter of lonely tribes, each evolving in its own direction drifting further and further apart, unable to help each other, unable to understand each other, separated by the silence. This is the tyranny of scale. It tells us that meaningful existence is local. It tells us that the dreams of conquering the universe are contrary to the way the universe is built. The universe is designed to isolate. It is designed to keep things apart. And perhaps, as we shall see, this is not a cruelty. Perhaps this is a mercy. Because if the walls of the prison are insurmountable, it forces us to look at the cell. And when we look at the cell, when we look at the biosphere, the complex web of life, the rare and fragile conditions that allow consciousness to exist, we realize that the cell is not a prison at all. It is a sanctuary. We are now approaching the crux of the argument. We have dismantled the physics of their travel. We have exposed the thermodynamic nightmare of their industry. We have highlighted the impossibility of their governance. But what about the creatures themselves? What about the person, the conscious observer inside the alien mind? If they are like us, and in the broad strokes of evolutionary logic, they must be then, they are haunted by the same demons that haunt us. They are not just calculating machines, they are feeling, fearing, hoping entities. And it is in this shared biological and psychological vulnerability that we find the true reason why they stay home. It is not that they can't leave, although the physics says they can't. It is that ultimately they discover that they shouldn't. To understand this, we must look at the nature of intelligence itself. Is intelligence a tool for expansion, or is intelligence a mechanism for self-destruction? The final barrier they face is not the speed of light, nor the heat death of the universe. The final barrier is the one located between their ears. It is the great filter that sits ahead of every technological species. And it is here, in the fragile interplay between power and wisdom, that the destiny of the alien is decided. We must begin by acknowledging a simple, yet often overlooked truth. Life is not a separate entity from the universe. It is a direct product of it. And just as a star is bound by the balance between gravity and nuclear fusion, a living thing, any living thing, anywhere in the cosmos, is bound by the balance between energy consumption and structural integrity. We have established the physical walls of the prison, the speed of light, and the laws of thermodynamics. But now we must turn our gaze inward to the prisoner itself. We must ask, what does it mean to be a biological entity in a universe that is hostile to complexity? There is a popular assumption in science fiction that biology is merely a soft problem. We treat the physical body like a suit of clothes, something that can be discarded, upgraded, or genetically modified to suit any environment. We imagine that aliens will have transcended their biological roots, perhaps becoming creatures of pure intellect, or integrating themselves into machines that can withstand the rigors of the void. But this view fundamentally misunderstands what life is. Life is not a substance, it is a process. It is a chemical reaction that has been sustained for billions of years, a reaction that is incredibly specific to the conditions in which it arose. Consider the concept of convergent evolution. On Earth, we see that the eye has evolved independently dozens of times. Wings have evolved in birds, bats, insects, and pterosaurs. Why? Not because these creatures are related, but because the laws of physics dictate that if you want to fly through an atmosphere of a certain density, there are only a few shapes that work. If you want to perceive the world using the electromagnetic radiation emitted by a star, there are only a few ways to build a sensor. Physics constrains biology. This means that if we were to meet an extraterrestrial intelligence, they would not be amorphous blobs of energy. They would likely be recognizable. They would have sensors to detect their environment. They would have manipulators to interact with tools. They would have a central processing unit, a brain to make decisions. But most importantly, they would have a history. They would be the product of a specific evolutionary pressure on a specific world. And this history is a trap. You see, evolution is not a process that strives for perfection. It strives for adequacy. It selects for traits that allow a creature to survive long enough to reproduce in a specific environment. It does not select for the ability to travel between stars. There is no evolutionary pressure to survive in a vacuum. There is no evolutionary pressure to withstand cosmic radiation. There is no evolutionary pressure to live for 10,000 years inside a metal tin. Therefore, any alien civilization is comprised of beings that are fundamentally ill-equipped for space travel. They are adapted to a gravity well. Their circulatory systems, their bones, their internal fluid dynamics rely on the constant pull of their home planet. We know from our own limited experience on the International Space Station that the human body begins to dismantle itself the moment it leaves Earth. Muscles atrophy, bones lose density, vision degrades, the immune system falters. We are Earth things. We are puddles of ocean water held in shape by skin, designed to function at 1 atmosphere of pressure, at 1 g of gravity. To send a biological entity across the galaxy is to subject it to a torture for which it has no defense. You can talk about artificial gravity and radiation shielding, but these are engineering band-aids on a fundamental biological incompatibility. The alien is a fish trying to walk across a desert. It can build a suit to hold water, yes, but the desert is vast, and the suit is fragile, and eventually the water runs out. But the biological constraint goes deeper than just the body. It extends to the mind. We must ask ourselves, what is the origin of intelligence? Why did we become smart? We did not evolve big brains to ponder the nature of the universe or to write poetry. We evolved big brains to hunt, to navigate complex social hierarchies, to outwit predators, and to manipulate our environment for survival. Intelligence is a weapon. It is a tool for competition. This implies that any intelligent alien species is, by definition, a competitor. They are not benevolent angels. They are the survivors of a billion-year war for resources on their own planet. They have aggression. They have fear. They have tribalism. These are not moral failings. They are necessary biological imperatives. You cannot have a complex brain without the evolutionary drive to use it for self-preservation. So, when we imagine a galactic civilization, we are imagining a society of aggressive, competitive, territorial animals trying to cooperate over distances that make cooperation impossible. We are imagining a United Nations of the galaxy, but with a communication lag of 5,000 years. It doesn't work. The biological drive for immediate survival, for resource acquisition, for dominance, does not map onto the timescales of interstellar space. A species that is aggressive enough to conquer its own planet and build starships is likely too aggressive to sit quietly in the dark for a millennium, waiting to arrive at a new world. The psychology of the apex predator, which is what they must be, is wired for action, for feedback, for control. Space offers none of these. Space offers only silence and waiting. It is a psychological void that would drive a terrestrial mind, and likely an extraterrestrial one, insane. And let us consider the ecosystem. We often think of an individual, a human, or an alien as a discrete unit, but we are not. We are walking ecosystems. We carry within us trillions of bacteria, a microbiome that is essential for our digestion, our immune system, our mental health. We are symbiotic entities. We cannot exist without the microscopic life that co-evolved with us. If aliens leave their home world, they must take their biosphere with them. They cannot just pack a lunch. They must pack the soil, the bacteria, the viruses, the fungi, the entire web of life that sustains them. A starship is not a vehicle. It must be a planet in miniature. And maintaining a closed ecological system is one of the hardest challenges in science. We have tried it on Earth, the Biosphere 2 project, and it failed. Balance is incredibly difficult to maintain in a small system. Waste builds up, gases go out of balance. A single disease can wipe out the crops on a planet. The buffer is huge. The oceans and the atmosphere can absorb mistakes. In a starship, there is no margin for error. A biological civilization in space is living on a knife edge. One system failure, one crop blight, one mutation in a virus, and the colony dies. The biological inevitability is that life is safer, stronger, and more resilient on a planet than it can ever be in a ship. This leads us to a fascinating concept known as island dwarfism, and its opposite, but applied to civilizations. When a population is isolated on an island, it changes, it diverges from the mainland. If a fleet of alien ships were to leave their homeworld and travel to a nearby star, the journey might take 1,000 years. In that time, the population on the ships would evolve, not just culturally, but biologically. They would adapt to the ship. They would adapt to the lower gravity, the higher radiation, the recycled air. By the time they arrived at the destination, they would no longer be the same species that left. They would be aliens to their own ancestors. They would be unable to interbreed with the home world. They would have different languages, different gods, different values. The empire cannot exist because the act of travel destroys the unity of the species. The galaxy acts as a speciation machine, breaking any attempt at a unified civilization into tiny, drift-isolated fragments. We see this on Earth. We are all humans, yet look how difficult it is for us to maintain unity across continents. Look how quickly languages drift, how cultures diverge. Now multiply that separation by light years and millennia. The result is not a cohesive galactic federation. It is a scattering of genetic dust, each speck forgetting where it came from, each speck fighting its own lonely battle for survival. Furthermore, we must address the energy cost of complexity in a biological context. We spoke of thermodynamics earlier, but biology pays a tax too. A complex brain consumes a massive amount of energy. The human brain is only 2% of our body weight, but consumes 20% of our energy. Intelligence is expensive. In the harsh environment of space, where energy is a premium, high intelligence might actually be a disadvantage if you are drifting between stars. You don't need to write symphonies or solve quadratic equations. You need to hibernate. You need to reduce your metabolism. The selection pressure in deep space is for simplicity, for durability, for low energy consumption. This suggests a horrifying possibility that a species that takes to the stars might eventually devolve. To survive the journey, they might have to strip away the very things that made them human or alien in the first place. They might have to become more machine-like, less conscious, less feeling, simply to endure the boredom and the scarcity. The creature that arrives at the other end might be a husk, a biological automaton programmed only to land and replicate, having lost the spark of curiosity that launched the mission. This brings us back to the idea of the great filter. We often wonder why we haven't seen signs of galactic civilizations. Perhaps the answer is that the transition from a planetary species to a spacefaring one is not a step up, it is a step off a cliff. It is a transition that biology cannot support. The planet is not just a place where we live, it is a part of who we are. Our circadian rhythms are tied to the rotation of the Earth. Our vision is tuned to the spectrum of our sun. Our psychology is tuned to the blue of the sky and the green of the forest. We feel peace in nature because we are nature. An alien species would feel the same connection to their world. Their purple mountains, majesty, their amber waves of grain, whatever colour they might be, are the anchors of their sanity. To sever that connection is to inflict a deep existential trauma on the species. So why would they leave? We project our own 15th century age of exploration onto the galaxy. We think of Columbus and Magellan, but those explorers were looking for spices, for gold, for land, things that were immediately useful and accessible. They were sailing across an ocean that was full of fish, breathing air that was free. The galaxy offers no such bounty. There are no spices on Alpha Centauri. There is no gold that is worth the energy cost of transport. There is no air. The economic and biological drivers for expansion simply do not exist in the same way. The advanced alien, therefore, is likely one who has realized that the quest for more space is a fallacy. They would realize that their biology is a lock and their planet is the key. They fit together perfectly. To try to force the key into a different lock, to try to live on a dead rock or in a floating metal can, is an act of biological hubris that ends in extinction. This realization that we are biological prisoners of our own success might sound depressing. It implies that we will never have our Star Wars cantina, never shake hands with a Vulcan, but look at it from another angle. It means that life is precious because it is rare and because it is fragile. It means that every biosphere is unique. If life on Earth is the product of a specific, unrepeatable sequence of geological and biological accidents, and if life on an alien world is the same, then these worlds are the jewels of the universe. They are the only places where the universe can feel, can think, can love. The vast, empty spaces between them are not there to be conquered. They are the velvet ropes in a museum, keeping the exhibits safe from each other. If we could easily cross the galaxy, we would bring our wars, our diseases, our invasive species to other worlds, and they would do the same to us. The impossible distances are the quarantine that protects the diversity of life. So, the alien stays home, not because they are stupid, not because they lack ambition, but because they are smart enough to know that they are biological beings, not gods. They know that their bodies, their minds, and their societies are woven into the fabric of their home world. They know that to leave is to die. And this leads us to the final part of our journey. If we are all trapped, if we are all isolated, what then is the point? If the physical and biological limits are absolute, are we condemned to cosmic loneliness? Or is there a different way to find meaning in a universe that doesn't allow us to touch? We have looked at the physics, the thermodynamics, and the biology. Now we must look at the philosophy. We must look at the meaning of the limits themselves. And so we arrive at a destination that is not a place, but a realization. We have traversed the impossible distances of the galaxy. We have felt the crushing weight of thermodynamics, and we have peered into the delicate, localized machinery of our own biology. In every direction we turn, we find walls. The universe, it seems, has conspired to keep us here. It has conspired to keep the aliens, if they exist there, on their own rocks, orbiting their own stars, forever separated from us by the great dark ocean of the void. To many, this is a source of profound existential dread. We are a species that grew up looking at the horizon. We sailed the oceans, we crossed the continents, and we instinctively feel that the stars are just the next archipelago waiting to be claimed. To be told that the horizon is closed, that the frontier is effectively infinite and impassable, feels like a defeat. It feels like a sentence of solitary confinement. It gives rise to a cosmic claustrophobia, a fear that we are trapped in a small room in a vast, empty house, and no one is ever coming to let us out. But I want to offer you a different perspective. I want to suggest that this silence, this isolation, and these physical limits are not a curse. They are perhaps the most important and beautiful aspect of our existence. They are the very things that give human life, and indeed any life, its meaning. Consider the famous Fermi paradox. Where is everybody? For decades, we have treated this as a mystery to be solved. We have searched for radio signals, looked for laser pulses, scanned the stars for the waste heat of galactic empires, and we have found nothing. The silence of the universe is deafening. Usually, we interpret this silence as a sign that we are missing something, or that civilizations destroy themselves before they can spread, or that they are hiding from us. But in light of what we have discussed, the energy costs, the biological constraints, the sheer physical impossibility of galactic travel, the silence takes on a new character. It is not the silence of a graveyard. It is the silence of a library. It is a silence born of wisdom. If civilizations survive their technological adolescence, if they do not blow themselves up with nuclear weapons or cook themselves with climate change, they must, by necessity, come to the same conclusions we have reached here. They discover the laws of thermodynamics. They map the galaxy and realize the distances. They understand the fragility of their own biology, and they make a rational, enlightened choice. They choose not to expand. They choose not to conquer. They choose to stay. The advanced alien civilization is not the one that spreads like a virus across the stars. That is a cancer, not a civilization. The truly advanced civilization is the one that achieves perfect equilibrium with its homeworld. They stop looking outward for resources because they have learned to cycle every atom, every joule of energy within their own biosphere. They stop looking outward for living space because they have stabilized their population. They stop looking outward for meaning because they have found it in the complexity of their own culture, their own art, their own science, right where they are. This resolves the paradox. They are there. They are out there, perhaps on millions of worlds, circling millions of stars, but they are quiet. They are not shouting into the void because they have no need to. They are content. They are living deep, rich, sustainable lives, insulated by the light years, protected by the laws of physics from the need to invade or be invaded. The silence of the universe is the sound of civilizations that have grown up. And this brings us to the profound implication for us, right here, right now. If the aliens are subject to these limits, then we are not falling behind in some galactic race. There is no star federation to join. There is no galactic senate waiting for us to invent warp drive. We are not a backwater province of a great empire. We are it in our corner of the universe. We are the only game in town. This realization strips away the final fantasy of the space age, the idea that someone is coming to save us. We have often looked to the skies with a kind of religious hope, thinking that wiser, older beings will descend and teach us how to generate clean energy, how to cure cancer, how to live in peace. But the physics says no, they are not coming. The distances are too great, and the energy cost is too high. Even if they wanted to help, they couldn't get here in time to make a difference to our current crises. We are on our own. And while that sounds frightening, it is also empowering. It means that the responsibility for our future rests entirely in our hands. We cannot abdicate our duty to this planet by dreaming of others. We cannot treat Earth as a disposable cradle, assuming that once we trash it, we can simply hop on a ship and move to Mars or Alpha Centauri. There is no planet B. There is no evacuation plan. The limits of physics act as a kind of cosmic parent, telling us you must clean up your own mess. You must learn to live here. And when you accept this, when you accept that Earth is likely the only home humanity will ever have, the value of this planet changes instantly. It ceases to be a resource to be exploited and becomes a sanctuary to be revered. Think about the rarity of what we have. We live on a planet where the temperature allows water to exist in all three states: liquid, solid, and gas. We have a magnetic field that shields us from the solar wind. We have an atmosphere that is thick enough to breathe, but transparent enough to see the stars. We have a moon that stabilizes our axial tilt, giving us predictable seasons. We have a biosphere of staggering complexity, a 4 billion-year-old heritage of genetic information that has produced everything from the microscopic tardigrade to the blue whale, from the fungus in the soil to the human brain. If the universe is indeed a place of insurmountable distances, then this complexity is not common. It might be unique in a volume of space so vast that the human mind cannot comprehend it. To destroy a species here, to disrupt the climate, to poison the oceans, is not just a local crime. It is a cosmic vandalism. It is the destruction of something that the universe cannot easily replace. The limits of physics, therefore, force us to adopt a new ethical framework. We are not conquerors of the universe. We are custodians of a rarity. If we are the only conscious observers for 1,000 light years, and the silence suggests we might be, then we are the eyes and ears of the galaxy. We are the means by which the universe knows itself. If we destroy ourselves, if we allow our civilization to collapse, it is like a light going out in a vast, dark room. The universe returns to meaningless, blind mechanism. This gives our lives and our struggles a tremendous weight. We often feel small when we look at the night sky. We see the billions of stars and feel insignificant, but the analysis we have done reverses this. The stars are big, yes, but they are simple. They are balls of gas burning according to simple nuclear laws. They are dead matter. We are the complex ones. We are the improbable ones. In a universe of entropy, we are the islands of order. In a universe of silence, we are the voice. The alien, sitting on their world on the other side of the galaxy, is likely looking at their own star and thinking the exact same thing. They are looking at their own version of the periodic table, their own laws of thermodynamics, and realizing that they, too, are the custodians of a fragile flame. We will never meet them. We will never trade with them. We will never fight them. But we are connected to them by a shared reality. The reality of the struggle to exist, to understand, and to persist against the slide into disorder. There is a beautiful solidarity in this separation. We are like lighthouse keepers on distant rocks, separated by oceans we cannot cross. We cannot speak to each other, but we can know that the other lights are there. And we know that our job, our only job, is to keep our own lamp burning, to keep the lens clean, to keep the wick trimmed, to make sure that in our little patch of the cosmos, complexity and consciousness do not flicker out. So, what is the meaning of the limits? The meaning is that they define us. A painting is beautiful because it has a frame. Without the frame, the paint spills out forever and becomes nothing. A melody is beautiful because it has a structure, a beginning, and an end. If it went on forever, it would be noise. Human existence is beautiful precisely because it is constrained. We are constrained to this thin shell of atmosphere. We are constrained to these few decades of life. We are constrained to this particular set of senses. And it is within these constraints that we create everything that matters. Love does not require faster than light travel. Art does not require a Dyson sphere. Compassion does not require a galactic empire. The things that make life worth living, the connection between people, the appreciation of beauty, the pursuit of truth, are all things that happen locally. They happen here. They happen now. The fantasy of the alien is a distraction from the miracle of the human. We spend so much time wondering if there are other intelligences that we forget how miraculous it is that there is intelligence here. We are the universe waking up. We are the stardust that learned to think. And we have been placed in a garden that is perfectly suited to our needs, protected by the laws of physics from the chaos of the outside, given the time and the solitude to grow. The physicist in me looks at the equations and sees impossible, but the human in me looks at the same equations and sees enough. Earth is enough. It is more than enough. It is a world of endless variety, of stunning beauty, of challenges that will occupy us for 10,000 years if we are wise enough to accept them. The challenge of building a just society, the challenge of understanding the quantum realm, the challenge of creating art that moves the soul. These are infinite frontiers. We don't need to go to the Andromeda Galaxy to find the infinite. The infinite is in the depth of our experience, not the width of our territory. And so we should not look up at the stars with regret. We should not look at the Milky Way as a prison cell. We should look at it as a cathedral. It is vast, yes, and we cannot touch the ceiling, but we are not meant to. We are meant to stand on the floor in the light of our own sun and sing our own song. If there are aliens, let us wish them well in their own isolation. Let us hope they have learned to love their worlds as we must learn to love ours. Let us hope they have survived their technology. Let us hope they are looking at our sun, a faint yellow dot in their sky, and wondering if anyone is home. And if they could see us, really see us, what would they envy? They wouldn't envy our rockets, which are pathetic compared to the distances involved. They wouldn't envy our radio signals, which are faint and filled with noise. They would envy our rain. They would envy our forests. They would envy the fact that we can stand on a grassy hill and breathe the air and feel the warmth of a star on our skin without a spacesuit. They would envy the biology that we destroy so carelessly. The ultimate lesson of the physics of interstellar travel is a lesson in gratitude. The universe has given us a paradise, and then it has locked the door and thrown away the key, not to keep us in, but to keep the darkness out. It has given us a chance, one chance, on one world. We are not cosmic exiles. We are home. And it is time we started acting like it.